Thank you, Max, for the introduction, and also a warmly welcome from my side for today's webinar and brief introduction into our new B3PG6. You may ask yourself, why does BASF develop the new PA6 GF30? Because there are so many on the market and a lot of competition is available. So therefore, I would like to give you a little bit background, so why we have developed this new product. The product development started already in year 2015. So where we see by our market assessment and customer feedback that there is still a need of an improved PA6 GF30 for ICEs. On the request from customers were on higher temperatures and still rising higher charging pressures. Wherefore we decided to even improve our existing B3WG6 GPX. So this was the reference product where we started to develop a new product. And the market within powertrain is changing dramatically in the last couple of years. Wherefore we decided to review this development and R&D project in 2017. To put the focus, to have a more broader focus on the product development, where we were looking then more on the e-mobility, the overall changes on powertrain when it comes more to hybrid and electrified engines. Wherefore we added additionally targets into this product development and decided that this product also has to fulfill the target to be electrical neutral. How does a product fits into our product portfolio for heat stabilized PA6 as well as PA66 products? As you can see, we are currently offering globally different kind of PA6 and PA66 grades with heat stabilization, depending on our customer requirements. And the B3PG6 should fulfill a much more broader scope. So starting from standard applications, as well as very high heat requirements, where we already see the borderline of PA66 grades. So some of the applications which nowadays still made of PA6 might be able also then to use B3PG6 in the future. So how does it work? For that one, we need a heat stabilized system. And as I mentioned before, we also decided to have an electrical neutral stabilization, because more customers ask for a metal halide free system, because by temperature, humidity, and electrical voltage, there might be a risk of electrical failures on electrical components. And therefore, BASF developed novel new P stabilization where the halide content is below 50 ppm. So therefore, we see there's a minimized risk of electronic failures by galvanic corrosion and short circuits. In addition to this new heat stabilization, we achieved a much higher heat stabilization of our PA6, as you can see here, and I think some of these stabilization systems are already known to our customers. You see the E and K stabilization system, the H stabilization system, and normally within ICE and powertrains use double stabilization, and with our P stabilization, which is metal halide free, we achieved temperatures up to 190 degrees C. How does the stabilization systems works? So therefore, we were looking on the surface on different stabilization systems. As you can see here, the surface defects after a heat aging at 200 degrees C, which is very high. After 2000 hours, you see the surface defects on a standard PA6 GF30 with a standard heat stabilization. Oops, sorry. Go back. I'm sorry, one moment, please. Or can I make it smaller? Okay, sorry. And below here, then you can see the PA6 GF30 heat stabilization, the tensile, cutted tensile bar of a higher heat stabilization, where the surface is slightly bit more protected and the defects are not that strong. And here you can see our new B3PG6, where the surface really protects the tensile bar, where you can more or less no see any defects on the tensile bar. Furthermore, we looked at heat aging at 130 degrees up to 5,000 hours, where you can see that the tensile strength, there's only a tensile strength drop of -4% after 5,000 hours and a loss of elongation at break of 35%. Why we were looking at 130 degrees, because this also shows that the heat stabilization already is active at lower temperature and does not need preconditioned or activated at higher temperature. Looking at heat aging at 150 degrees, you see the difference, strong difference between, shown here in dark blue, our B3PG6 in comparison to the reference grade shown here in gray, the GPX. So this, you see the improvement, especially after 1,500 hours in tensile strength as well as in elongation break. And to have more references, we also edited the standard BWG6 as well as an PA66 grade, and the PG6 is always better than the other grades. Looking at 180 degrees, the difference becomes even more visible. Again, here in dark blue, you see our new product, B3PG6, with a very low loss in tensile strength and very low loss in elongation break. So the tensile strength is a loss of -6.8%, and elongation break is loss at 48%. In addition, we tested the B3PG6 at 120 degrees elevated temperature. So the product have been before heat aging at 150 degrees and 3,000 hours, and then we did an elevated test. And here you can see the difference of our reference grade B3WG6 GPX in comparison to our B3PG6. And there is a difference of 10% in tensile strength as well as 22% in elongation break. The difference to the reference gate becomes even more clear and visible at elevated temperature when we look at heat aging at 180 degrees C after 3,000 hours. So here the tensile strength is 33% higher than the GPX and 100% more in elongation at break. For some of the applications we are looking at, vibration welding performance is important. So, and that was also a target, and to increase the vibration welding performance. And as you can see here, I would say at 0 hours, the weld line performance is almost on the same level in comparison to the GPX. And after 500 and 1,000 hours, the B3PG6 outperforms the GPX in welding performance. And after 1,000 hours, the difference is an increase of 25% in weld line performance. For the processing and production of parts, we also looked at the flowability of our new products, and the target was to reach the similar flowability And as you can see here, the B3PG6 is in between the GPX as well as the standard B3WG6. So we did a flowability test on a flow spiral with a thickness of 1.5 and 2 millimeters, where you can see that the flowability is given. In a nutshell, you have seen that there is a strong improved long-term heat performance on our new B3PG6, which have been highly improved, as well as the higher weld line strength, wherefore also we are expecting that the burst pressure is even more higher than on our new product. The flow and cycle time is equivalent to our current PA6 GF30 systems we are offering. And a laser marking is possible limited. Yeah, this really depends on the laser our customers are using, and we are currently looking to improve even this laser markability. One very important point, looking on e-mobility, this new product offers a high and metal-free stabilization systems, wherefore our customers must not have any concerns on electronic failures on their components. And the price is really price competitive if we compare this to existing PA6 GF30 products in the market. And in addition to that, the product, all products we are normally developing within BASF are global available and locally producible. So this is in a nutshell. And now I will hand over back to Max to go to the question and answer session. Thank you very much.
Thank you so much, Andreas, for these insights. Yeah, as you said, we are coming to the questions. As I said at the beginning, please use the Q&A function, which you can find on the lower right on your screen. Yeah, and in the meantime, we have received several questions. Some of them are going in the nearly same direction, so I tried to combine them. So I will start with the first one. So Jens, I think this is a question for you. The contact metal halide is given by below 50 ppm. Was this measured, and what is the content?
Yeah, so that is true. We have an internal specification of not more than 50 ppm of halogen content. And of course, this has been measured. And for the first sample, we had a value of roughly 40 ppm. And we have to make sure that with every production, we will have a metal content below, or halogen content, sorry for that, halogen content below 50 ppm.
Okay, thanks a lot. The next question is about laser markability. So is this product laser markable, and is it identical to Ultramid B3WG6 GPX? So I think, Martin, maybe you can answer this question.
Yeah, in principle, based on the color, the laser markable, we cannot define this product as a typical laser markable product. And based on the color, it should be similar to that compared to the existing B3WG6 GPX. But be aware for future versions, we are aware of this requirement, and we're thinking about producing also such laser markable grades.
Okay, I think you can still don't mute yourself, because I have the next question for you. Is there also an uncolored version available?
Just at the moment, we produce only the black color, because in the combustion area, always the colors are black. But if there is any customer requirement, any customer need, we can check if an uncolored version can also be offered but based on the customer need.
All right. Okay. Thank you very much. And the next question, what about chemical resistant versus B3WG6 and A3WG7? Maybe Jens, can you give us an answer?
Yeah, I can try to, because chemical resistance is a very complex topic. So if you compare this new B3PG6 with, let's say, a standard B3WG6, with all the chemicals that are on my mind, I would say we are on the same level. Typically, if you're comparing this to a PA66, the PA66 offers a higher crystallinity compared to a PA6, and therefore the standard chemical resistance of a PA66 is always slightly higher compared to a PA6, but it always depends on the type of requirement, and it's not only the medium itself, it's also the time that it's being exposed to. So therefore, I have to say it's a really complex question, but in general, at least it's on the same line compared to standard PA6 products.
Okay, thanks a lot. And regarding the glass fiber content, is there only a GF30 available or also higher glass fiber content?
I can take that question as well. So we just started with the portfolio and we decided to make a successor of the GPX material. And therefore, we started with 30% of glass fibers, but of course, we are looking into the expansion of the portfolio. We are looking into new PA66 grades. And of course, we are also considering higher glass fiber contents. And it's very dependent on our customer demands. If there are customers that are requiring this material with 58% glass fibers, for example, we can do that. That's for sure.
Okay, thank you. So Martin, coming back to you, is it possible to produce this material in light colors?
Yeah, it's the same as I mentioned it in the uncolored version. At the moment, we have this black color material only, but if there is any need to produce in bright colors, we can check this if it is possible to use an uncolored version to color it in any bright color and to check if the quality is good enough to offer it in the market.
Okay. And next question to you, is it possible to replace the material by B3WG6?
There is no reason, I guess, why not, or why this new B3PG6 should be anywhere worse compared to the W grade. Of course, if the material characteristics of the new material is suitable for the application, I would say yes, there is no reason why not using the P grade instead of the W. Be aware if the characteristic should be suitable for the application, but in principle, I would say yes.
Mm-hmm. Okay. So Jens, coming back to you, the next two questions are for you. So according which specification and norm will the ppm be measured?
It's basically an internal measurement. So we are referring to the general content of halides within the compound, and then it's calculated to chlorine. And typically, chlorine is the most abundant halogen in the compound.
Okay, and is the oil aging behavior also better compared to already existing grades?
I have to admit that we not really looked into this topic by now because there are so many measurements we have to conduct. But typically, oil heat agings in oil are better for the material than heat aging in air because the oxygen has to get into the oil and then diffuse into the polyamide. Therefore, I think that oil aging is on the same level, meaning higher than for standard grades. But it's also a question of what type of oil you are using, because standard engine oils are not really aggressive, and therefore we don't see any problems with that. But in the case of, for example, gear oils, you have to look into the kind of stability or stabilization used for this material, and then it might lead to some more complex questions about resistance.
Okay. Then another question, or some more questions which are nearly the same. Is this P stabilizer also available for PA66 and PPA in the future?
This is something we are currently looking into. So at the moment, we are developing a corresponding PA66 grade. In the case of PPA, I'm not quite sure if we can really use this kind of stabilizing system. This is still under discussion.
Okay. Thank you very much. Martin, do you have any target applications? Is this based on some of your market research? Do you have any plan to expand your PE stability grade? Okay, these are 3 questions to you.
Yeah, but in principle, our target, of course, was the combustion engine to put the material for index manifolds, for example. Therefore, we have the typical material characteristics which are required for index manifolds. This in combination with any sensors, for example, for electronic elements, and therefore we selected this P stabilization with low metal halide content. Of course, based on all the requirements from our customer, we are focused now on electric vehicle to produce to put this material on. And if there is a requirement for any other, I would say, content of fiber than the one, we are willing to adapt this material to other wishes of customer. But this is always in combination with the customer needs. And of course, we are willing to talk about this.
Good. And Martin, the next one is about availability of the product. So is it already available, and also is it globally available?
At the moment, we have material available for samplings. For if a customer needs any material for a sampling process, it's available in limited volume, of course. But be aware, it's a polyamide 6, and we have at the moment this big issue regarding shortness worldwide, and therefore it lays in the same area as other polyamide grade at the moment. And we have to I would say, organize to talk with you how much material is needed and when can we deliver. It will be available worldwide, of course, but based on the shortage we have at the moment, this material will be in the same, I would say, in the same field.
Mm-hmm. Good. So Jens, next questions to you. Any inputs about its shrinkage, tolerance, accuracy with respect to PA66 plus GF30?
Yeah, shrinkage and warpage of PA6 versus PA66 is always a problem. So it's not that easy to replace a PA66, let's say GF30, with a PA6 GF30 in the same mold. But if we are talking about a direct comparison between the new P stabilized material versus a standard PA6 GF30, then there's no difference in shrinkage and warpage.
Okay. And is there any change if the material is colored? So are the technical requirements the same?
So at the moment, we are only thinking about a black color because we are tackling high heat applications. And if you think about an unkerneled material, for example, at 180 degrees, this will turn dark over time. And therefore, if you start with a black material, then the black color will not really change. The mechanical performance of a colored material should be similar, but it depends on the kind of coloration you're using. Especially white coloration might be a problem from time to time because of the employed pigments.
Okay. Another question to you. Can stabilization additives influence liquid silicone rubber material performance?
So there are some additives that might have an effect on liquid silicone rubber, but these are not being used in our materials. So we think that we will have a good adhesion to LSR.
Okay. So let's have a look. The next question is, 1 second, please. Oh, here it is. To Jens again, do you offer P stabilization on PA66 compounds, and how does it perform?
On PA66 compounds, I think that was a question raised earlier. Yeah, we are looking into this. We are developing grades at the moment.
Okay. Thanks. Then please stay in the line, because the next question also to you. You have been investigating crystallization and hydrolysis behaviors on this polyamide PA6GF30 in superheated water and glycol.
Yeah, so hydrolysis resistance for PA6 and 66 is always a special topic. And in the case of a PA66, we have a portfolio for hydrolysis resistant materials. And meanwhile, we also offering hydrolysis resistant PA6 grades, but these have to be modified in a certain way. And here in that case, for the new P-stabilized grade, we wanted to have a successor of the GPX, and therefore hydrolysis resistance was not scope of this topic. And if you're really thinking about that, yeah, this can be something we can develop in future, but at the moment, this P-stabilized grade is not really hydrolysis resistant.
Okay. Thank you so much. Now we are coming to the last question, and this is also for you, Jens. How will the test results change if the material is colored? As you know, the high temperature performance materials are used for high voltage, high current applications where the temperature requirements are very high.
Yeah, it's, let's say, complicated because it depends on the kind of coloring. Yeah, so we didn't really look into this because for transportation and automotive applications, most colors are black. But we can think about colored materials, and it depends on the kind of coloration. Especially some pigments might have an influence, but this has to be tested for each specific coloration.
Great. Thank you very much. Thanks, Jens and Martin, for all these answers, and a special thanks also to you who have joined the webinar and asked your questions. And as I said at the beginning, you can find the recorded webinar, let's say, beginning of next week on our website. And if you have any further questions in the next days or in the next weeks, you can call our UltraPlast info point or visit our website plastics.basf.com. So thanks a lot for joining. Stay healthy and goodbye.
BASF. We create chemistry.